welcoming to the podium Mr. Amit Walia.
So I guess it's the credit and the free pizza that gets everybody here? Is that right? And some incentives haven't changed since I was in undergrad. Free food, by the way, stays along with all engineers. Stays along with me too, even now. So thank you all for coming. I think it's, first of all, so great to be back in campus. We were chatting before. The energy of undergrad campus just is infectious. This year and last year, I went for my both business school reunion as well as my undergrad reunion. Clearly, as you can see from the salt and pepper beard I have, I'm far too aged now. So it was quite a few years since I got out of undergrad. But every time you go back to your undergrad or even your grad school, and I've graduated from business school in 2001, so it's 15 years. You just kind of feel the energy there. It's just awesome. So I think some of my best days were when I was in school because there's no worries. Life is always good. So enjoy those. When you get to the real world, no free food. You got to earn your food. I actually always sat at the back bench myself. And every time I sat there, I remember my strategy professor would drag all the people from there. It was her pet thing. She would start the class and literally after 2 minutes say, all of you at the back, can you just come in the front? So you can come in the front as well. I do not bite. I do not hurt. What I thought I'd do is make it interactive and fun. Obviously, first of all, Informatica, we are actually very closely tied with NC State. You are actually a school from which we hire quite regularly from. I have seen so many interns and who have become full-time hires as well as college hires coming from NC State, and it's just amazing to see people graduate and come here and spend their journey with the company. So it's actually a pretty fruitful relationship. So I'm actually thrilled to be here on campus and see their campus. As I was telling some of your alums at Informatica I was coming here, they were pretty excited. So I love to take a picture at the end and show them what it was like. What I thought I'll do is that the world we live in, at least the world I live in with Informatica, the world of data, by the way, which is the world I think all of us live in, is an amazing space right now. I thought I'll share with you what's happening in that world, what are some of the amazing opportunities, both from a business point of view as well as a technology point of view, and then kind of connect the dots for you, and then we can open it up for any kind of questions that you may have. All right? So I'll begin with a story. I should begin with a little bit of setup, and then I'll give you a story. So we kind of believe that this is a very unique time across the world. In the world, what we think the data economy, as you hear those phrases, there are three. This is a phase where the world is, where with regards to data, 25 or 30 years ago, it was a data 1.0 world. And the data 1.0 world was nothing else where, all organizations across the globe, they were automating their business processes, right? Accounting function, HR function, sales function, and they were using applications to automate those functions. And data was nothing else but just a sheer output of that. There was nothing strategic about data. People lived in the app. It was awesome to automate those processes. I mean, SAP and Siebel and Oracle, all of those applications, as you may, Bond and PeopleSoft, that was that revolution. Data 2.0 world was actually when people said, look, now I have automated my applications. I actually have some data about the organization. I want to connect the dots. And you start hearing things like data warehousing come along. Analytics came along, where you said, look, I'll take some data from my sales systems, I'll take data from my HR systems, and I will connect them to do something more. I'll learn something more. I'll do some analysis. To merge all of that data, now you went from an individual app-centric world to connecting the data in a data warehouse. Now you can do analytics. So you see organizations like Teradata, Cognos, Business Objects, some of that stuff came along. That was data 2.0. But where we stand today, and where the world is going for the next 10 years actually is a very, very transformational space. And we call that the data 3.0 world. And in the data 3.0 world, I'll give you a story to kind of relate to what I think is transformational. How many of you have watched The House of Cards on Netflix? I love that show. Netflix is not known for making shows, right? And you know House of Cards has won a lot of awards. You know how Netflix ended up making House of Cards? It was a complete data-driven approach. What Netflix did is they said, look, you know what, we're going to make a show. But typically when you do a show, it's like me, I'm a guy, I may be successful or I may be an amateur, I have an idea. I'll go, let's say, to my friend Kimo here, said, Kimo, I got a great story, I got some characters I want to put in, you want to give me some money? If I'm a rookie, Kimo either will toss a coin and bet on me, or he'll say, get out of here. If I worked with him before, he'll give me some money, the chances are still 50-50. That's how it works. Pretty risky bet, right? Think about it, it's like lottery. What Netflix did is that, nope, the probability of success should be more than 90%. So what they did was they said, let's see, first of all, which kind of an audience we want to go after. So they did a survey. They said, look, we are looking for a male demographic of this age and a female demographic of this age. And for that demographic, boy, what kind of genre of show would be a big hit? They went for a thriller. Then they did the research. They said, political thrillers, people like political thrillers. So they did all that research first. Then they said, you know what? Let's go around the globe and try to find a show. The House of Cards, I don't know if you know or not, is actually a British show. They went there, they bought the rights, then they brought it back. Then they said, now what do? We got to put some people in it. Let's do another survey, a data analysis. Which characters resonate with people? Kevin Spacey came up, Robin Wright came up. So before they even shot a single pilot scene, they had done so much incredible analysis that they had de-risked their production by a whopping 90%. And voila, when they made the show, it was a big hit. That's a very different approach to doing business. That's not how businesses run traditionally. Traditionally, we make things, we hope they'll go well, there's a lot of analysis happen, a lot of strategy meetings happen, believe it or not, but we kind of hope and pray. Hope and pray doesn't make a successful company anymore. This is a data-driven approach, that's data 3.0. Another example I'll give you. Amazon is working on something called predictive shopping. They're going to predict, what's your name? Dewey. They're going to predict what Dewey wants, they're going to ship it to him, and they're going to hope that he will keep it. How do they do that? How do they do that? It's again a data-driven approach. They know him through his Amazon shopping experience, hopefully if he shops on Amazon through the mobile app. They know what he does through the Amazon website. They probably know what he does on Facebook, all the good stuff that he does there. They know what he does on LinkedIn, what he does on Pinterest, what he does on Twitter. Where is he? Through his mobile device, through the IoT device, through a sensor. They're going to collect all that data and do a sentiment analysis, say, you know what, I think Dewey wants something right now, let's ship it to him. And hopefully he'll keep it. That's retail done in a very different way. That's the data 3.0 world where each and every company has to make business model decisions, strategy decisions, their success decisions based on data. Nothing else but data. And the ones who will do it right will be amazing winner. It's a winner-take-all economy, as you all know. The ones who will not transition to that world will die. And that's the world in which you are graduating into. And that's the world, when I go around the globe talking to a lot of large companies, I see them either struggling with, trying to figure it out, or the ones that have figured it out, I can see will be winners. So that's what we think, as I see, is like the data 1.0, the data 2.0, and that's the data 3.0 world in which you're stepping in. Now in that world, there's exciting stuff happening. How do you bring it together? So clearly from a business point of view, you can imagine, right? That makes sense. So I think you may have heard the word fintech. What is fintech? It's technology companies trying to disrupt finance. I don't think anybody in this room probably likes to go to a bank branch anymore. You probably do your banking through a mobile device very easily. At most, you probably go and withdraw money from the ATM, and that too will die away at some point. But think about it. So the fintech companies are going to disrupt that for the banks. But the banks know the most about their customers. Yet, they're stuck in the old world. They cannot change it. They still have branches, which carry cost. They still have ATM machines that carry cost. They still have people as tellers that carries cost. The fintech companies have no cost. They're on the World Wide Web. They know a lot about you, and they will give you a delightful experience that you want. That's the world we are all graduating into. So in that world, obviously, there are business decisions, but there are very fundamental technology decisions, right? There are very fundamental technology. So in that context, obviously, you hear the word big data. a lot, right? Big data, IoT, sensors, all of that stuff flies around, right? And they all are in the context of something. So one of the biggest disruptions is that now for any business, how do you understand all of this stuff that's going around in the context of your customers or your factories or even your products like an airplane? And that is a complex mathematical problem at the end of the day. It's a complex mathematical problem because think about it, like the number of variables, we all know you increase the number of variables, it becomes a more complex problem, right? So all that we are doing with all this data is the more data you collect, but you have to still have some level of problem solving around it, right? It's a multivariable mathematical problem. Now that I know what you like from 50 different dimensions, I have to make sense of it. So it's an algorithmic mathematical problem. Big data allows us to do three things. Number one, first of all, it allows us to scale out in a fundamental way. Traditional databases, as you know, fundamentally cannot scale out. The architecture of a traditional database is limited by design. I mean, the amount of data that we lived in the previous world was very, very small. Now we're talking about weblog streaming data. You go click on, I mean, Yahoo's website has billions of clicks on one day. They got to get and that's where Hadoop actually came from. Hadoop came from Yahoo. Yahoo had so much weblog data that Yahoo realized that traditional Oracle databases just couldn't scale. So the Hadoop foundation happened at Yahoo. Amar Abdullah, who's one of the founders of Cloudera, actually was at Yahoo. Mike Olson, they were all at Yahoo, and that's where they founded Hadoop because they needed a fundamental scale-out infrastructure that could basically be at some kind of an infinite scale. So number one, it's a mathematical problem where you want to first collect data at scale, which is big data's first level of problem. Second is you want to make some sense of this data, right? Because this data by itself means nothing, right? We got to bring it together and we got to make sure it can do something in the context of the business problem we are solving. So take the example of GE. GE has aircraft engines, right? And aircraft engines are flying at any given point in time. So many planes are flying, aircraft engines are everywhere. They're all sensors. Every little part of the engine has a little sensor. They're collecting data from it, right? So first of all, they want to bring it into a Hadoop cluster. But then they want to do something special with it. And that's where a whole layer of technology called data management comes into play, which is where company Informatica plays. Data management is a very critical piece of technology because if you move up the data stack, one is databases where you just dump data. But think about it this way. If I have data on him from 100 sources, or if I have data on engine on 100 sources, I got to first bring it together. And a lot of it could be junk too. So a lot of transformations have to happen, right? Filtering, sorting, joining, making sense of it. So basically that part of the logic has to come in to first make sure that you can bring data together. You want to profile the data, make sure it's clean, it has good quality. All of those things are in the data management stack. And then you do some analytics on that data. And by the way, even analytics layer is under a lot of stress, right? Because doing scale-out analytics, doing big analytics, right, where the underlying data is of volume, is not what traditional analytics was built for. And that, in the world of big data, at a very, very simplistic level, is a massive business problem, as I articulated, that is being solved, and a technology problem that is being solved. And they are both unsolved problems today. It's not necessarily that they're both solved problems. I'll give you a great example of an unsolved problem. Hadoop is a great infrastructure to bring lots of data. But I don't know if you study this, but there is this whole batch versus real-time streaming. Hadoop is not great at true real-time. So think about it this way. Hadoop is so new that it is still not fully disrupted traditional databases, but Hadoop is not necessarily real-time. It is micro-batch. So you got to go to streaming databases. So you'll start thinking of here things like MemSQL and all that are streaming databases, right? Much more real-time. So there is an amazing amount of technology work that is happening right now in this space. Because this is genuinely, for the next 2 decades or so, transformational opportunity in the industry, across every industry. And the technology problems are still unsolved. People have solved it in piece parts, but there is a lot to be solved at every layer. So take, for example, Hadoop even more. There are different engines in Hadoop that come and go. You guys have heard of MapReduce, Spark 1.0, 1.5, 2.0's come out. Have you heard of Flink? All these engines are still you just imagine, this technology is so new and the engines have changed so rapidly. It's still an unsolved problem from a technology point of view, which is exciting for, I guess, folks in this room. Because in this once in a lifetime opportunity where data is going to be fundamentally transformational for every business across the globe. Every business. I gave you examples of Netflix, what Netflix did, Amazon. I gave you example of GE. ConocoPhillips is an oil company, right? Each wellhead is an endpoint for them. They have to figure out what is happening at that wellhead. That's an IoT big data problem. So this is transforming every business, but technologically, still an unsolved problem. Still an unsolved problem, and that makes it exciting for folks like us. All of us who are in the business of developing technology, helping end customers make something valuable from that technology happen for them. That's what makes it exciting for us, and that's what makes it exciting for folks sitting in this room, because as you step out, graduate, and finish, and you go into the workforce, there is a lot of cool stuff to do. And examples that, as I talked about, right, in this whole big data stack, IoT stack, the amount of infrastructural stuff to do is immense, all the way up to the analytics stack, where even visualization at scale is not fully solved. I was reading when you had some of your professors' names up there. I forget the name of the gentleman. I think he does some work on scale visualization, I guess, right? I think that's an area that, by the way, is a pretty unsolved problem in itself. Tools like old BI tools really cannot scale, and even the new ones are still struggling to figure it out. So you actually sit at the precipice of a very terrific opportunity where if you're choosing your technology areas of focus, I mean, there's so many areas to go to. Networking is there, system infrastructure is there, data layer is there. In my opinion, data layer, and I'm, by the way, I started myself as a systems guy myself. I've gone up the stack all the way. I was at the storage layer at one point in my life. I went to the apps layer at another point in my life, and I came to the data layer. Where I find the data layer very exciting is because A, it is not too app level, it's not too system level, and boy, oh boy, you see the value that you deliver. And it has so many cool problems to be solved. So that layer for me, at least that stack, the data stack to me, is a very exciting stack as you're thinking about, obviously, what you do in your careers going forward. Now, let me pause here for a minute because we can take questions, but love to kind of steer the discussions in different ways. We can go down a pretty technical route, or we can go down where the trends are. What do folks in this room want to kind of steer towards? Sorry? Trends? Okay. I always want to check because I guess we can go either way. I think as I talked about trends, if you think about all the unsolved problems here, if you're thinking about your decisions stepping out and where do you work and what do you do or what kind of cool pieces of work you do, the trends of solve analytics in a true big data world right now is the hottest thing to do. And I'll give you an example again. So I talked about ConocoPhillips, right? My colleague over there, Jitesh at the back, obviously he works with them because he actually helped them build some of their initial IoT infrastructure. ConocoPhillips' problem is what? I have wellheads, right? If a wellhead goes down, that costs them millions of dollars. Millions of dollars. So they want to make sure that I want to know everything that's happening with the wellhead real time. The wellhead, by the way, is nothing else but like a sensor like who you are. If you wear a Fitbit or this Apple Watch, you're tracking your health from here. That's what they want to track from the wellhead. So a consumer problem just becomes an enterprise problem. It's the same problem, same technology in a different way. So what they want is to collect data from their real time, which is, by the way, an IoT endpoint and a big data problem, and dump it into some scale infrastructure, but they also want to compare it against their existing data to see, is this wellhead going good or bad? Then they can do something with it. They can do what? Predictive maintenance. Saves them millions and millions of dollars. That's where companies are spending money. Obviously, they can get real-time information to see whether a wellhead has gone down or not. That's just a binary decision, gone down or not. But how do I make sure that if it's going to go down in a month, I can fix it before it goes down? Same as an engine problem. By the way, it's not only a operational efficiency problem, it's a security problem too. If an engine will go down while you're flying, that's a pretty risky problem. So if you just start seeing the implications of data everywhere, It's literally everywhere. It's literally everywhere. And it fundamentally changes life. Fundamentally changes life because it touches performance. Fraud is another area where, by the way, big data is heavily used in a big way. So I'll give you an example of, anybody know Western Union? Western Union is a company that does remittances. If I want to remit some money from here to another country to some family member, they help you do that. 220 countries they are in. So when you go do a remit some money, let's say you take some $10 and you want to basically send it to me. And if you and me have an agreement that you have to send it to me, you want it to be transferred ASAP. The moment I give you $1, it should go away. Any time lag there is not good for you. But it's a massive fraud problem. It's a massive fraud problem, and a lot of national security interests are implied because it could be terrorism linked also. So they have two problems. They have a customer satisfaction problem where they want to transfer money from you to me quickly, but they want to check for fraud. And these are mutually competing goals, because to check for fraud, they would like to hold it for a week and check every transaction, but they really cannot do that. They really cannot do that because you'd be pretty unhappy. Your money's gone out of the bank. So it's a scale problem. First of all, they're solving it for millions and millions and billions of records. And they have to do all kinds of matching of different heuristics. They want to know everything about you, what you do, which location you come from, what kind of money you're sending, have you sent it before or not, what is your profile. They have to do all of this matching. Just think of the algorithmic work that's happening at scale in a very, very short amount of time. That's a data problem. But just think about the implication for that company. If they do not do it well and somebody does it well, they're going to be out of business. So, so all these examples are, you can see every type of company in every part of the life is getting impacted by data 3.0. And they are all big data problems. And they're all massive, massive value creating problems for companies across the globe. So to me, as I said, what excites me is that obviously as we develop technologies in that space, as we work with customers across the space, they are pretty cool pieces of technological problems to solve. But at the end of the day, you see the impact of them right away too. You make an impact in somebody's life. You make an impact in, another example is FDA. FDA, when they give a seal of approval to a drug, the multivariable problem that they have to check, the atom, if they have to do a recall, they have to know which location, which truck took the drug from that location, which atom, which compound, which molecule is involved. It is becoming a very multivariable problem. You can actually save lives if you can actually predict, or you can basically figure out what went wrong rapidly, leveraging all of these data technologies. So what data is truly transforming us is not only businesses, but human lives in a very fundamental way. And again, as I said, it's still unsolved because each day the volume of data increases. Each day the type of data increases. We call it the variety. In the world of data, you will see volume, variety, veracity. They're all changing. And it keeps raising the bar for the complexity of the problem. So the problems that we have right now with our customers or that can change the world are immense. And to me, at the end of the day, the more difficult the problem, it's exciting to solve, and it creates bigger value, which to me is rewarding because you either, obviously, it's an intellectual solution, plus at the same time, you end up creating a lot of value, not only for each and every, wherever you work, whichever organization you work for, whatever appeals to you, but across the whole landscape of what you work, it changes people's lives. So those are some just amazing examples that as I go around, as we go around as a company and we see what people are working on, what some of their problems are, what they want to solve, that's the kind of stuff that they're grappling with. And we obviously, obviously colleagues of yours who are working at Informatica obviously engaged in solving those problems in a very, very meaningful way. Any questions? what kind of technology, I'm obviously you guys have people here, generally, let me ask you a question, I'll steer you towards something. Have you, at this stage, how many of you in this room have a sense of what part of the technology stack you would like to be more excited, you'll be working in? Have people thought through that, or is still, generally it's still a fair game? Curious in this room. Hardware, software, infrastructure, people have you guys given some thought to that, or it's too early?
I would like to go into the predictive analytics, the one which you described, like predicting the shopping which he does.
Yep.
Like something similar to that. So yeah, I would like to go in that.
Got it. And predictive is across the board, obviously. Analytics is the last mile of the data problem. First, you have to solve the data problem. Analytics is nothing else but an output to solving an algorithm which involves data. So needless to say, predictive analytics is one of the hottest places. All of this, the examples that I gave you, fraud, wellhead, it's nothing else but predictive analytics, right? That's what companies are dealing with. Fraud, by the way, is a very big problem right now in the world of data. So I'm sure you get calls on, or sometimes your credit card company changes your card or sends you an email saying that something happened and here it is, a free credit card monitoring, something like that, right? It's a big problem. And the whole insider attack situation in the world of security is actually a pretty big risk. So what is happening again in the world of data is that if you go to companies right now, everybody wants to give access to data to everybody. But the problem is, just imagine, if I gave you access to all the data of the company, I just created a Snowden risk, right? I just created a Snowden risk. Because the risk to me from an outsider is less than a risk to me from an insider, because I will trust you and I'll give you all of my crown jewels. That's another predictive and analytics problem that companies are solving and we are engaged in. How do we predict an insider attack? It's again a multivariable problem where you have to figure out based on all of the activities you do, all the heuristics you do, how you have, whether or not you are at risk to create an insider attack. So, for example, in our predictive analytics for security, what we look for is, we know from the vast volumes of data a company has, based on our technology, we can profile the data and figure out what is sensitive data, whether it is your credit card data, whether it is your social security data, whether it is your sensitive health record. And then the trickiest thing is to track where it's sitting across an enterprise. Imagine NC State. Your social security is with NC State. Imagine the number of places it could be. You don't know. But if I'm an insider, the weakest link is where I will go. And I know that. That's what Snowden did, right? So having that view and then having a prediction analysis to say, you know what, you typically log in from this building and your dorm that you live. But suddenly if somebody stole your credentials and I see a login happening from some strange location at a strange time, that's a risk. Let me do something. That's predictive analytics of the highest order. Something from an insider attack point of view is very big that by the way, every company across the globe is working on right now. Every company across the globe is working on. That is, by the way, one of the biggest data problems that we are solving for customers. Go ahead.
How do you avoid false positives?
That is a big problem. False positives, the biggest risk in security is solving for false positive. Having spent 6 years at Symantec, basically every security company, and false positive, the only way you solve it is, your algorithm keeps improving over time. But at the end of the day, your algorithm keeps getting better as the more and more data you track. So your antivirus products that you have on your laptops, how do they get better? The more the volume of antivirus, the more the probes they have across the globe, the better they get. So in some cases, actually, big data has helped there, because when you can collect a lot of data at rapid scale, quickly, a lot, you are able to, in that case, remove the false positive. But false positives in the world of security is one of the biggest problems. And it's nothing else but you have to just keep going at it. It's not necessarily just improving algorithm, it's also learning from the data you collect and how you improve it.
My question is why there is so much hype about big data from past 2-3 years. Whatever examples you gave, like fraud detection, it was already there financial technology companies were already dealing with that problem. The planes, operational maintenance of engines, and performance analysis of machines in factories, that was already there. So why there's so much sudden change in the perspective of people? People started to thinking about in the way that you are trying to depict us, or is it really a company like Informatica trying to sell its product to the customers that you can use this in this way, or is it really a hype, or customers are needing that?
So I would not worry about the company. Think of the macro trends that I talked about. Big data came along because, as I said, take the ability for, I gave you the example of most of the companies, the number one thing every company wants to do is sell more to their customers, right? Classic thing everybody wants to do, right? I know you, I want to sell more to you. The thing is that 5 years ago, there was not enough data about you floating around. There was 5 years, 6 years ago, basically you went to a website and pretty much that's all that you did. Just think about what you do now. You go to so many different apps. You have so many different sensors that you're carrying. You basically are creating so much more data than before, that what companies are trying to do is that basically get smarter about you. So even a simple thing like an email campaign that companies do, typically they'll do email campaigns, that's what companies do. There is a cost to that. And in the old world, in the absence of a lot of data, the email campaigns, the false positive of an email campaign is ridiculously high. It's single-digit success rate. But the more they collect, like the Amazon predictive shopping example that I talked about, the more they collect from data about you, their ability to predict what you want and to give you an email campaign, taking that as an example, gets a lot better. That's what they're doing. So you are leaving a trail of data everywhere today. You are leaving an average human today creates gigabytes of data every day. You yourself are creating terabytes and terabytes of data every month. You don't realize. The Pokemon Go app that probably, I don't know how many of you play Pokemon Go right now. The location that they're tracking about you is ridiculous. It's actually, what they're tracking about you will tell them a lot about what to do with you in terms of locations they go. Just imagine today Pokemon Go has no shopping in it. But if you went to Central Park and you were doing Pokemon Go collecting over there, I can give you an offer for Starbucks next to it because I know exactly where you are. That scale of data creation was not there 5 years ago. And because it was not there, the need for a big data stack was not there 5 years ago. Now it is there, and hence the requirements. It's a very different world. And giving you the aircraft engine example, companies are not pretty good about it. You know how the old world was? Actually, the plane did go down, and they went to GE's hangar, and then they fixed it, and they sent it. Today, that had a lot of cost. So by the way, for a company like GE, they used to have these contracts with aircraft companies that, by the way, if my plane goes down, there's an SLA that you have to fix my engine in a certain number of days. If you don't do it, you start paying me money. It's an insurance. GE doesn't want to do that. So by collecting all this data, now they're able to do it. They're able to predict. So they can tell an aircraft company, you know what, I think in the next 2 weeks, you should bring this engine down, send it to us so we can quickly send it back to you before it actually goes down. So just think about that. For a company, revenue goes up or cost goes down. They both are happening at a very rapid rate right now. Does that help?
So as I see it, it's the analytics is sort of like an arms race where you use certain flags, especially in case of frauds, to detect certain behavior. Now say, how do you solve a problem where the perpetrators get aware of those predictive flags and then they find their ways to go around those? So isn't it like an arms race of redesigning or rethinking what sort of analytics you're using at a constant basis?
Between two competing companies, you mean to say?
Just for a single company. So if I'm a credit card company, I look for these specific events to predict frauds. And then the perpetrators are get aware of because of some report of some kind that if I avoid this, they won't predict.
I see. When you went competitors, I'm confused. You mean people who are trying to hack their way into it? Those. I see. Oh, for sure. Security, by the way, is one of those things where it is always you're catching up with the hacker, somebody who actually will always outsmart you, which is why all the large companies in the world, as you know, they have their security white glove program where they actually proactively want you to hack into their systems and they'll pay you for that. So that is always true. But you know, again, this is where big data more data helps, right? Because the ability to predict something just gets better. But the point that you're making is always true in security, by the way. There is always a guy, as I always say, there is always a smarter guy sitting in a room somewhere that will outsmart you with the best you will build, and then you have to keep going at it. So it's always a game of chess. You're outsmarting the bad guy, and the bad guy is outsmarting you. In that context, security hasn't changed, and I don't think it'll ever change. Security is always one of those, which is why I was giving you the example of insider attack. Forget the outsider for a minute. That is a game of chess, by the way, that security industry will forever play. The biggest risk comes from insider attack. Forget that for a minute. I have given you are my insider, I've given you access to my special data. How do I avoid? I don't know when your intention changes. How do I make sure that you don't mess with me? That is a much bigger problem. And that is a more complex problem to solve because I have actually willfully given you access to data. So that's where I talked about a lot of heuristic analysis, that's where big data helps to make sure I can really understand your patterns as best as possible. So if anything abnormal happens, by the way, you may not be doing something abnormal. Somebody hacks your credentials. At least I should know. That, by the way, is a much, much bigger problem right now. Like a rogue trader. You see this, like, you know, all these banks, I think there was a movie also, The Rogue Trader, right? How do you prevent from one bad trade that can cost $1 billion to a bank? And sometimes it's building over time. So those patterns you need to track. The insider attacks have cost the industry a lot more than outsider attacks, by the way, in aggregate. Billions of dollars have been lost by banks in a trader willfully committing a bad trade than somebody from outside hacking into and taking sensitive data. Yep.
So you talked about data.
Hang on, the mic.
You talked about data security. So you talked about the sheer volume of data which companies have, like Informatica or other big companies. So if the data is so big that I am unable, or the big companies are unable to make sense of it, why not make it, like, outsource it and like make it open and let other people try their hand at it? And because anyways we are not able to handle that much data, we are just collecting. So why we are so adamant on securing that data when it is of no use?
Okay, let me separate the two. I actually didn't even talk about Informatica at all because I didn't want to make any plugs. Let's separate what Informatica is, because that's not what Informatica is. A software company. We build data management software, right? Data management is about data integration, data quality, master data management. We build software, data security software. We build software that other companies buy to solve their business problems. So we don't collect data. Informatica's, like NC State could be a customer of ours. If NC State said, look, I want to really do a much better analysis of which classes my students are going to, which classes do they like, and I want to, you know, do some, so they could be a buyer of my product. Now, customers, why would they share their data? I mean, that's the most treasure trove they have. If I'm Bank of America, my data is my data. The most precious thing that a company has, by the way, again, the reason why I'm passionate about data is, the most precious thing that a company has is not the networking device, not the ERP application, not the database, not the window, not the chair, not the facility. It's the damn data. The data about what the customers have done with them and data about what the employees have. So that's the most important thing companies have. By the way, in the world of cloud, it becomes even more profound. The example I always give customers is, by the way, in the world of cloud, you don't own the application, you're renting the application. So if you rent a house, you own nothing in that. You don't own the house, you own the chair that you may have brought in the house. What do the customers own? Data. Nobody wants to share their data. If you are a customer of Bank of America and not a customer of Wells Fargo, that's their competitive advantage. No, they know everything about you, so they'll never share it. Why would they share it? That's their competitive advantage. So sharing what? Where open source comes into play is the technologies that we are building, some problems are very generic. Can we just make sure that we can solve, like we talked about some algorithms, some problems of scale. Can we make them open source so all of us engineers can solve that problem collectively, because the collective wisdom is better than, let's say, Informatica's wisdom or somebody else's wisdom, pick any company. That's where a lot of work has happened in open source. That is the premise of open source, right? That is the premise of open source. That, hey, today I have a Spark engine. Not everybody has to go develop their own engine. It's a common engine, and you can write a piece of code and submit to Spark. I can write a piece of code. That's where definitely open source had added a lot of value. However, open source has its own limitations too, because now let's say you and me have built an open source product. Hadoop is an open source product, right? But if you want to go use it somewhere, somebody has to buy it. So that becomes, but open source is a very value creating thing. And it has helped a lot in accelerating innovation, no doubt about that. So things like Spark, things like MapReduce, the whole Hadoop, the whole Hadoop stack, the whole Apache Hadoop, project is nothing else but an open source project, and it has added a lot of value in the industry, definitely. And it is a disruptive innovation, no doubt about that. Just like Linux came along years ago, and it has disrupted the whole server and the whole hardware stack, if I may. I think there's one behind, and then we'll come to you. Yes, no, you go ahead, please.
Thank you for your time. I'm actually from the soft sciences. I'm from psychology. I'm finishing my doctorate there. And when we talk about data, we always dealt with data. And it just now became more abundant, right? But having, in my experience, the studies that we do, having more data doesn't necessarily mean it's actually easier and to derive the insights and answer your questions. And the example of NSA and as an agency that probably has the most access to any kind of data in the world shows that, especially about human behavior. So my question is that, how did your company and maybe your products address some of these challenges about getting insights from data, especially about people? Thank you.
No, it's a very fair question. You're absolutely right. Data in itself is nothing. What you do with data is where the value is, right? So I can be sitting on treasure trove of data, but if I don't do much with it, where companies like Informatica, like where we help, is make sense of the data. So I gave you some concrete examples. The whole space of data integration or data quality, where you have volumes of data, right? First of all, every company wants to be able to get data from a lot of places, right? So we help them get data from a variety of different sources, like thousands of sources. And then our ability to bring that data, now it's a lot of volume of data. You don't want to get that data in a raw format, right? You want to make sure you can filter them, join them. There's a lot of transformations that happen. I gave you some very basic transformations. We do that. We make sure that the data is of right quality. So for example, if I'm getting a customer data, your name can be written 10 different ways. You don't want all of that stuff to come as 10 different ways. You want it to be cleaned up and mastered, so we do that. So from this crazy vast pool of data, first we get it, we make sure it's of high quality. So we provide all of those value-added data products to make sure that when you want to do analytics, now you have a very reasonable set of data to do something with. And it's called data integration, data quality, master data management. I won't bore you with the names, but that's the data flow, the data management flow. And in the end, also securing that data to make sure that it's safe and secure. It's masked, that nobody can hack into it as much as level. So that's what Informatica does. And that's what the data management layer is, which is critical for you to then do all kinds of analytics on top of it. Otherwise, it's what we call, it's a data dump or a data swamp. Somebody else had a question here? Yes, you need to get the mic, please.
Yeah, thank you for your time. So recently, it was in the news about the Target incident that happened, wherein they were using analytics data and they found out about the pregnancy status of a woman, and they were sending them advertisements or coupons based on whatever data they collected. Now, I read through that case study and I could understand that they were not collecting any medical data. They were just looking at patterns of what they were buying.
Yep.
And just based on that, they were able to accurately
Yes.
predict.
Yes.
So based on such data and all these companies collecting so much data and pushing it in the cloud or in their own storage, do you see that the industry is now getting any concern about the ethics, about what kind of data and how to ethically handle that data and not create an embarrassment out of it?
By the way, the story is actually even more humorous than this. I think the story actually is that a dad found out that his daughter was pregnant based on Target sending at their home all this. And because they figured out by triangulating that she was shopping X, Y, and Z, so she must be looking for, I think they sent her diapers or something like that. No, it's a very genuine question. Now let's separate the technology from the moral and the ethical questions of data. Data raises a lot, it's a very spooky boundary. It's kind of like you and me on Facebook, right? Facebook knows a lot about you and me. It does. Google knows a lot about you and me. Trust me, more than my wife knows about me at times, I guess. That is a very, very important part in the world of morality and privacy that's happening. You know, banks sit on a lot of data on you. And a lot of companies have struggled whether they have so much data on us that can they sell that data. So by the way, there are full streams of work on this one, the morality and the ethics and privacy of data. Obviously, there are laws, very stringent laws. Needless to say, there are laws in US, Europe has even more stringent laws. But the morality of that is that companies are struggling with it too. And I agree with you. Separating my practitioner hat or a technologist hat as a user myself, it disturbs me because I see what companies are collecting on us and what patterns they can make of us. So that's a very, very, it's a very real and alive, thriving discussion. And I can tell you, it's a boardroom discussion. It's a boardroom discussion. I was sitting with the chief operating officer of a big bank. This is a big bank on Wall Street, and that's the discussion they had. That look, it's a boardroom discussion, the morality of it, the ethics of it. And customers, and they worry because one bad move, and if all of us as consumers revolt, can have a massive impact on their stock price. So on the psychology or the ethics part, it's a real lively debate. I think it's there. It's not solved. And I think, by the way, companies are being cautious about it. They're struggling with it. In that case, I think Target made what I called is a harmless mistake, but think about it in something else. It could be really intruding in your and my privacy, right? Really intruding in your and my privacy. So it's a very fair question. Very fair question. Sometimes when I come back after a couple of meetings as a consumer, I'm spooked. What's available out there on all you and me. Yep, at the back.
You mentioned data cleansing.
Yes.
It seems to me that if humans have to do that, that doesn't scale. So is there some automation to cleanse that data?
Yes, no, absolutely. Actually, when I said the word data quality, a pretty significant chunk of that is data cleansing. As I said, one simple example of cleansing is just 5 ways your name can be spelled in a database. And I'll give you a real example of that, by the way, where it becomes, I'm giving you guys all these examples because I know when I was sitting here in my undergrad as an engineer, the struggle for me was how do I relate the technology work I'm doing to something real life? So I have refrained and tried hard not to get into any Hadoop stack discussion. So I'll give you a great example of that. London Airport, because they are a user of our product, so I can say that, it's a live customer. Every time you go to any airport, like you go to New York, JFK or whatever, when you are at the immigration line and they're looking at your passport, they're running a check on you. Your name can be spelled a zillion different ways. How do they know you are you? They need to clean the data at the back wherever they are, and it's a cleansing and mastering problem, as we call it in the world of data. And products like Informatica are used to do that. It's a national security risk. So the city of London uses our product to make sure that, let's say when I cross the line and my name is Amit Walia, there can be multiple permutations of spelling mistakes. It's the right Amit Walia, not the guy on some no-fly list. So that's On another very harmless scale, it is just making sure that I get the right name inside, because if I'm going to sell you an email campaign, I'll waste if I send you to the wrong email. So there, you can see two different spectrums of same problem, cleansing, but solving some very different business problems. And it is automated. It's called data quality is the way we call it in the industry, doing data cleansing.
As an extension to his question, you said that there could be 5 different ways my name could be spelled.
Yep.
What about a scenario where some other person has the same name as me? How do you not jumble up the data relating to both of us? And we might have intersected at some point or the other, so how
Right.
do you avoid that?
I mean, there's a lot. So, I mean, in the world of databases, like the primary key, foreign key, right? I mean, your name is not necessarily going to be the primary key for you, right? So, your social security number or your passport number or your home address, there are multiple things that get triangulated in that case. So, it's not just, so obviously, the whole idea of a piece of technology is to make sure that you can't run into, that is a very elemental thing to solve for. So, there are different, the one primary key and multiple foreign keys, if you take that concept for a minute. But again, in the world of big data, the triangulation can be a lot more complex, and you can be a lot more smarter about it, right? Because the number of variables around you can be many more now to make it a much more accurate result. But yeah, I mean, you don't want that to happen. One more question then. Or maybe not.
Well, thank you so much.
Well, thank you. Thanks for the time. Appreciate it.